Hello? Good morning? No. Good morning? I'm not sure. Oh, there we go. Hi, everyone. Welcome to Cedar 2022 and happy Juneteenth. It's nice to see you all finally in person. My name is Meghan LeMay, and I am one of the two Cedar student reps on the CSSC committee. This is an exciting day for Zishun and I. We've spent the past year preparing for today, so it's nice to see it come into fruition. The workshop today is based on the feedback from last year, so I hope everyone enjoys it. Every year, Student Day is one of the most highly attended sessions at Cedar for both students and scientists. The goal is to prepare students for the rest of the meeting and provide a reference for further understanding by introducing research tools and equipment to provide students and the rest of the community with an introduction or reminder of the underlying facts and assumptions of the various topics, and to give students a kickstart for the rest of the workshop. I am the outgoing Cedar student rep, and so we're looking for a new Cedar student rep. So if you want to nominate anyone or yourself, please email Zishun and I, and we will do something with that.
Okay, thank you, Megan. So this is Zishun. I'm the student rep for the year of 2022 and the year of 2023. So now I'm going to introduce our student events that's scheduled during the Cedar workshop. So the first thing first is that we're going to have Student Day today, which the theme is Reconnect and Act. So I'm very excited that we're doing the in-person student Day finally. So this is based on the feedback that the previous years our audience enjoyed the lightning rounds a lot, so we're going to still doing the lightning round mainly. And then we still have long talks about connections between DoD and Cedar, and we will have another long talk about sounding rockets with students' participation. So the first lightning round will be focused on the Back to Basics lectures. It will be 15 minutes each, and the next lightning round will be hands-on tutorials on instrument model data. And then we have the third lightning round focused on scientific communication. So we will use Slido for all the questions. So if you could please scan this QR code, then it will direct you to the Slido page. Or you could also enter the event code as 3240997. When you submit questions, please address the speaker's name at the beginning. For example, questions to Dr. Larisa Goncharenko, and then have your questions there. And then you can also check through all the questions and give a thumbs up on the questions you like. So we will have the most likely chance to read the top-rated questions. I hope everyone already got the QR code. And then we will also remind you via email about this Slido link. So our next student activity during Cedar is that we're going to have student lunch on Monday. We have invited 9 scientists from industry and academia. So if you like to join, please come and grab your food and sit down with the table and talk with the scientists. So our poster presentations is always been an essential part for our students. So here are 2 QR codes, which are the web page for the Tuesday and Wednesday poster presentations. If you scan this QR code, then you can check on the posters that uploaded by student poster competition participants, and you could browse the posters ahead of time. And then if you are interested, then go find him and talk to them. So starting from this year, we have 9 student co-conveners to help co-convening the Cedar workshops. So these are the workshops listed here that's having a student co-convener. And I'd like to introduce our student volunteers team. Please stand up. And, and we are really happy that we have a big amount of student volunteers this year, and none of them will serve as student co-conveners. Most of them will help with the student newsletter, and we have sli.do moderators for today. So big help. I thank you to the team. So starting from the year 2020, we start working on the student newsletter. It will be written mostly by students and will be good for record to students for the further reference. So at the left is the volume 1 of year 2020. In the middle is the volume 2 of the year 2021, and this year we will have the volume 3. So we expect to release this hopefully in July or August. And then we will have all the manual ready in the newsletter, and also question and answers. If the questions are not taken during the day, then we will have the answers collected on the newsletter. So how do I communicate beyond Cedar? So there's 3 different ways that we have the Slack channel of Cedar, and we also have a student channel in the Cedar. So we will post some position advertisements or updates about Cedar students and such. It would be nice to have everybody join in there. And we also have a Facebook group about Cedar science. And we also have a Cedar mail list. So this is just a reminder that it would be good to have the access to those communication tools. So we will need your feedback to shape the future of Cedar Student Day. As what you did for the previous years, it's been always helpful. So please, this is the feedback link of a Google questionnaire. So we will remind everybody at the end of the day and also at the end of Cedar. So please give us the feedback, and your help to shaping the future of Cedar Student Day would be really appreciated. All right, so this is a quick reminding slide that we welcome student rep nominations all the way until the end of this Cedar workshop. So please email Meghan or me, and we're happy to work with you.
Now we have a short presentation from the CSSC chair, Dr. Larisa Goncharenko, to give an overview of the Cedar workshop. Larisa is originally from Ukraine and came to the US 26 years ago. Her first position was a Cedar postdoc at MIT Haystack Observatory, and she remained at Haystack Observatory for 26 years. She studies ionospheric, thermospheric systems using different observations, both ground-based and satellite, and models as well, and is particularly interested in ionosphere-thermosphere variability related to lower atmospheric drivers. Her most known papers investigate ionosphere-thermosphere changes related to sudden stratospheric warmings. Let's hear from Larisa.
Okay, how do we start slides? Okay, well, we're trying to get going. So it is my 26th year, and at Cedar, I come to Cedar every year, and I always thought I know everybody. And I look at you and think, wow, I do not know you. And I am very enthusiastic and very excited to get to know you, to meet you, to understand what you are doing, what are future plans, and also to welcome you to community and tell you a little bit more about how Cedar works, what Cedar is, so that you feel maybe more comfortable and you can find your place in this community. So first of all, welcome. We have not seen it, we have not met in person for 3 years, and this is really nice to finally look at each other and talk to each other in person. Of course, if you're at this meeting, you already know that CEDA stands for Coupling Energetic Dynamics of Atmospheric Regions, and you can think about CEDA in just the word CEDA in in 3 different aspects. First of all, CEDA is a research program under NSF Atmospheric and Geospace Science section. And so CEDA science is supported by NSF, funded by National Science Foundation. But CEDA also is, the word CEDA is also used to refer to the research community that works on CEDA topics. And this research community is actually really quite large. It's several hundred people, maybe of the order of 300 to 400 people. And this is a lot. This is the largest community on, if you consider other countries. This is the largest community working on these topics. In a lot of other countries, active also in this area of research, number of people working on the topic, maybe you can count like maybe few dozens at the most, or maybe even less than 20. So this is really large community. It is mostly United States based, but we always welcome international collaboration, and we okay, that doesn't look right. Welcome international collaboration. And I'm trying to go back. And my last point about CEDA meeting, CEDA is the annual meeting where we can meet and discuss our progress. And also CEDA is NSF-funded, NSF-based. We really try to keep lines of communication open with other agencies. We always try to invite a representative from other agencies, NOAA, NASA, and so on, to CEDA meeting. And we have presentations on Tuesday, and I know sometimes students find them quite boring, but I really encourage you to listen where agencies are moving, what are they thinking, what are their plans for several next years, so you can see how your future can form, where your professional path could lead you. So as far as CEDA domain, as you know, we study focus of CEDA is ionosphere, thermosphere, mesosphere, and so this focus region, but large emphasis is on the links both to regions below and regions above. And for example, one of the examples, if somebody studies volcanology and will come to CEDA meeting, and they will not really get enough of audience who really understands fine details of their studies. But if you study how volcano eruption affects upper atmospheric layers, you will be welcomed and will get you will have a lot of response and a lot of interest to your research. And we have, as an example, we have an exciting session this year about effects of Tonga volcano eruption. In the same sense about coupling to regions above, if your PhD research is on fine details of solar wind, maybe CEDA is not the best meeting for you to get feedback on your research, but if you want to investigate how solar wind affects ionosphere thermosphere system, you will find a lot of response and a lot of understanding and a lot of feedback here. CEDA, there are other sister programs, I would say. If CEDA is interested in ITM system, there is GEM community that focused more on magnetosphere, and SHINE community that focused more on solar science. And of course, all boundaries are relative. So this is one of the important things that you need to remember. Cedar work is organized around 6 Cedar strategic thrusts. That and you can see them here. They're really sort of like open questions. Really not very specific. But thrust lines of research that encourage people to think about Cedar science strategically. It encourage undertake system perspective of geospace, explore exchange processes, explore processes related to geospace evolution, develop observational instrumentation strategies, fuse knowledge base across discipline, and manage might manipulate data and models. And you can read more about Cedar Thrust on our updated website. A little bit about Cedar community. It is actually really quite diverse. And just to make sure that you kind of understand a little more how it functions and where you can be more comfortable, where you can get more feedback. Large part of research community is actually people who develop instruments. There are a lot of instruments that are supported by NSF program, and in general, a lot of large set of instruments and networks that have been operational for decades already. So people develop different instruments, like, and I'm going from mesosphere and up, LiDARs, meteor radars, MF radars, air glow imagers, Fabry-Perot interferometers, HF radar, SuperDAN, and so on, so on, so on. Within last decade, there was quite a bit of emphasis on developing CubeSats and small-sat instruments, also supported by NSF program. So these people are, again, just instrument developers, a lot of them with a lot of engineering background and engineering expertise. On other hand, we have some percentage of community that works purely on model development. And you will see in a lot of abbreviations during this meeting models like WCAM, WCAM-X, WAM, IP, Time GCM. United States actually is home to most developed set of theoretical ionospheric thermospheric models and coupled models. We are leading in this area. And there are a lot of theoretical models that don't even have specific name. So this is active area of research, but again, only some portion of people working on it. Most people are users. They do not develop these tools, observational tools or modeling tools. They analyze data. They use all of the available tools to address specific science question. And again, this is really, really flexible. So in some sense, you need to think where you will benefit, what session you will provide better feedback, or what you need to talk about. So even if people work on some models or some data, it is very, very likely they're actually interested in a broad research area. Cedar, important to understand that Cedar is a really grassroots effort. It is operated by and managed by Science Steering Committee, which is voted for by community members voted for 3-year term, and a Science Steering Committee includes NSF representatives, international representatives, student reps. So you are strongly encouraged to apply and to become student representative. Main thing that it's initiatives are not dictated. They do not come from above, from NSF. Community is for scientists and by scientists. And it is really different compared to how some other communities and how some other meetings function. Like one of the examples, you can suggest individual section on some science topic, and you can convene it. And it's actually different compared to how some other meeting functions. You can come to this meeting purely with the focus to discuss observational campaign or establish natural international collaboration. And this is one of the main areas how this type of meeting is different from other meetings, for example, like AGU. So you can expect the you probably look already at the agenda, and you see how we try to compile the program. So we have a lot of science highlights, like most recent, most exciting things that people published within last year or last several months. We have a prize lecture and distinguished lecture that highlight significant accomplishments on a larger time frame. We have updates from agencies, international multiple workshops. I advise you to look at town halls and look at participate in these discussions, in particular in the future of ground-based instrumentation. One of the exciting part, we will have not just banquet, but we will also speaker who will be talking about science as art, with inclusion of art and music. We're in Austin, after all, and I think this is very could be very interesting. Important part that you are here probably because you like science, but you certainly will be overwhelmed. I participate every year, and every year I'm overwhelmed. There is a lot to absorb, so don't. It's okay to be overwhelmed, and it's okay to feel like you do not understand some of it. Just come to talk to people and just try to participate more. So how you can participate? How you can get most out of the meeting? Try to get involved as much as you can. Participate in sessions, volunteer student rep. Help to convince session or to prepare session for next year. And one of the things, if you think something is missing, help to organize it. I have several examples of things that we organized just beyond science. We had things like soccer games, salsa dance, women's breakfast, and so on. If you think there is some areas missing and that really needed and would be interesting for people, suggest it and organize it. And this is example of how Cedar works. Several slides, a little bit of information about Cedar database. As I said, we have a lot of instruments, large networks. Where is their data? You can reach a lot of the data in the Cedar database, which is supported by MIT Haystack Observatory at this point, and it has a collection of archives of data from many different instruments. And you can see on the slide 22 incoherent scatter radars. It's some past radars that are not operational right now, MST radars, MF radars, meteor radars, and huge part of it is GNSS total return contact, which is our most used data set. The database is distributed, but all sites archived at Cedar Madrigal. How you can access the database? There are several ways to access, and if you need just to understand, like take a little small sample of data, understand what's happening, you can go to website, browse to look at small file downloads or look at summary figures. You can use interface to create scripts to download larger chunks of data. Really important aspect that database is developed to the point that it has several APIs in Python, in MATLAB, in IDL. So what I usually do, I work on my script during the day, and before I'm ready to check out for the day, I click it and it downloads and processes a lot of data. So in the morning when I'm ready to get back to work, I already have a lot of data processed, plotted, and so on. So you do all of this through software. You go and do web browsing and downloading small chunk of data only when you're trying to understand, but when you need to process a lot of data, you do everything through software. one of the final things, it is very easy to add your data to the database. Contact Bill Rightout, who can help you with this, but often when instruments developed and connected to medical database, what we have, you wake up in the morning and you see what data was taken overnight and you see already summary figures. All of that work is already taken for you by database. So if you have data, it's very important and very useful for you to have it connected. I think I will end with this, and please ask questions. Find me at the meeting if you have any questions to ask. And most of all, welcome. Please learn, communicate, enjoy the meeting, and I'm real glad to see you here. We do not have time for questions, right?
Thank you, Larissa. Our first talk is on the connections between the Department of Defense and Cedar. All questions will be asked via Slido, and the questions will be answered during the Q&A at the end of the presentation. Please upvote your favorite questions for the speaker, and all questions not answered today will be answered in the student newsletter. Colonel Diana Loucks serves as the Director of Advanced Physics in the Department of Physics and Nuclear Engineering at the United States Military Academy at West Point. Her Army career spans 25 years, 9 duty stations, 4 continents, 3 specialties, Signal, Army, Space Operations, and now a West Point Academy professor. Colonel Loucks completed her graduate work in aerospace engineering sciences at the University of Colorado Boulder. During her master's studies, she was the communication subsystem design lead on a graduate design team for the Air Force Research Laboratory, sponsored by University Nanosat V competition winner, the Drag and Atmospheric Neutral Density Explorer, DANDY. Stemming from her doctoral work, Colonel Loucks was recently named the first West Point recipient of the National Science Foundation Faculty Early Career Development Award for her research focused on the physical mechanisms and operational effects of ionospheric interference on unencrypted navigation solution parameters. Here is Colonel Loucks.
Good morning. Thank you so much for that introduction, and thank you so very much for letting me come up here and talk to you about this subject. So I have to echo a lot of what Larissa was up here saying. I joined the Cedar community in the summer of 2015 after having finished about a year of grad school on my PhD program, and I couldn't spell Cedar, much less knew what it stood for, but now am, I guess, a card-carrying member of the Cedar community. So I really hope that while you are, in the military we say drinking through a fire hose, right? There's a lot of information coming at you today. And I really hope that you take the time, take notes, ask questions, come up and talk to all of us. The one thing that I love about the Cedar community is that we are open. You come and you talk to us, you ask us questions, we'll put you in touch with the right people, and we want you to succeed. We want you to be successful. We want you to be able to help add to the body of knowledge. And also add to the operational effect and operational impact, not just for the military, but just worldwide. One of the biggest questions I always get, and you'll kind of see it throughout on my summary slide for West Point, is why does the Army even care about space? Well, from a military perspective, we're the #1 ground user of on-orbit space capabilities, which means space weather is an important thing when it has an impact on our missions. And so there are people like me within the Army and across the Air Force and across all of our sister services that, I think he's trying to wave at me, that do research in this area to try to understand what's going on so that we can better talk to not just the commanders in the field, but all of you. And I'll get to a little bit of the topics later on, and then I have a talk on Thursday as well as a poster on Wednesday night. One of the contributors, or the other contributor to this presentation, was Major Rob Perez. He's actually in the back of the room. He's waving right now. Hi, Rob. So Rob is one of our junior faculty members. He attained a master's degree from Naval Postgraduate School, which is one of the units that I'm going to talk about in the presentation, and is doing space debris mitigation research. Okay, next slide, or do I do this? Okay, so here's the agenda I'm going to follow. Really, I want to talk to you about and let you know that there are opportunities within the Department of Defense. I'm hoping in subsequent years I can come up here and actually talk about the national labs, as well as other agencies that exist within the military, and just at the federal level, so you can kind of see some of the ways and paths that you can get through research within this community. I'm going to focus on the service academies. There are 4: the United States Military Academy at West Point, which is where myself and Rob work, the U.S. Naval Academy, U.S. Air Force Academy, and then, of course, the Coast Guard Academy. 2 graduate schools within the DoD. So Air Force and Navy both have a graduate school. They institutions. Like me, I went to University of Colorado for my graduate degrees. We prefer to have that diversity of thought, and so our funding sends officers out across the world, actually, for graduate degrees. And then, of course, the Coast Guard Academy, and then, then one of the military units I'm going to cover is the 2nd Space Squadron. 2nd Space Squadron at Offutt Air Force Base, and I'll get to their mission here in a minute. Okay, so space weather at West Point. What is USMA, the United States Military Academy? Longest standing military academy. It's, if you remember in the Revolutionary War, it's the gateway to the Hudson River. It's about 45 minutes north of New York City in the Hudson River Valley. It's our rock-bound Highland home, as we like to say. And our mission is stated up there. The Corps of Cadets is about 4,400 strong. That number for all of the service academies is set by Congress in the National Defense Authorization Act every year. Our faculty, somewhere around 5,000 to 6,000. We have a fluctuation in our faculty. I'm a permanent professor at West Point, so when I retire from the Army, that's when I theoretically would leave West Point. Major Perez is on an operational assignment to West Point to teach, so he's actually only with us for, and faculty like him are only with us on average 2 to 4 years. They go back out into the operational force and then can have opportunities later on to return. And each of the service academies has that similar faculty population. About a quarter of our faculty population is permanent. Is half. About half of them is permanent, and a quarter of that of the overall population is actually civilian. Either U.S. Code Title 10 covers permanent faculty tenure track positions, so you can achieve tenure at West Point. But we also have what we call overhire position, where as long as the funding is available, we can hire somebody and bring them in on the Title 10 side. Gives them an opportunity to teach, but also to do research, interact with the cadets, and be part of our mission to develop leaders of character. There are some examples of the research, which I'll talk about again during my talks later on this week, but definitely focusing specifically on GNSS or GPS in the ionosphere in the Arctic region, and also some looking out into the broader envelope of space, going all the way out into the magnetospheric effects. We do have other space programs at West Point: balloon satellites, small satellites, rocketry, you name it, including the remote sensing with the geospatial information sciences and even bioastronautics. So we do span that, the topic list of the space community. So for the Naval Academy, they have an aerospace engineering major. West Point does not. We have a space science major. At the Naval Academy, they do have I guess there was an animation I didn't get out. They do have a small satellite program. There are some acronyms up there, and I'm going to provide the student organizers with the more details, so you'll actually be able to see the spread out of it. But the Naval Academy is in Annapolis, Maryland. They are our rivals in sports and one of our, of course, sisters and brothers in arms. They use a lot of just like we do, a lot of the space science research and the engineering research in order to facilitate understanding of space and its applications. There it goes. There we go. Okay, so United States Air Force Academy. More of you may be familiar with this just because you can see it from I-25 on the north side of Colorado Springs. And they do a similar mission to the what we do at West Point, except for Air Force. They have roughly the same population, again, mandated by Congress, same as the Naval Academy. They have cadet capstones, both on the engineering side, so small satellites and rocketry, but they also have what is shown up here, the Space Physics and Atmospheric Research Center. Jeff McGarg is actually going to be here this week, so if you want to ask questions to him about the research that they do, but it very much parallels a lot of the research that we do at West Point. And in fact, between West Point, Naval Academy, and Air Force Academy, and Coast Guard Academy, we've actually started coming together to try to do collaboration on things like cube satellites and even rocketry. There we go. Okay, so the Coast Guard Academy. A lot of their current work is actually in the polar regions. One of the projects that's highlighted up there is the Polar Scout project, but they are specifically interested in what's going on and how it affects particularly GPS, but also communication systems as they attempt to navigate waters that are not available because of the recession of the ice cap. Coast Guard Academy is a much smaller institution. Roughly 1,200 cadets attend, and they graduate 300 to 400 every year. But again, the research is there to supplement the curriculum and enable space education at the Service Academy. Okay, so now we're going to move on to graduate schools. I mentioned the Naval Postgraduate School. Again, Major Rob Perez was a graduate from that institution with 2 space-related degrees. Naval Postgraduate School is in Monterey, California. Yes, it is a gorgeous place to go. One day I'll make it there. But there is a lot of research highlighted up here specific to being able to understand the impacts of the systems. And so while they are doing science research, they are also trying to do the operational side and understand what's the impact to commanders in the field, to soldiers, to sailors, to airmen, to anyone around the world, and what's going to impact their operations. They have a population of about 2,800 officers, and about half, just over half of those are actually resident, doing work on graduate degrees, and the other part of that population are typically non-resident. Now the Air Force Institute of Technology, they have a Center for Space Research and Assurance. A number of colleagues of ours on the Air Force side have actually been through the Cedar community. Janelle Jennings is actually I met her at one of these conferences. She attended AFIT, got her PhD, and when I get to the 2nd Space Weather Squadron, she's now the commander of that squadron. So the community is actually very much a part of this. AFIT is at Wright-Patterson in Ohio. And their focus has primarily been civil engineers, according to their mission statement, but again, it's much broader, and they do use space research to enhance the education, knowledge of space, and there's actually a significant portion of their officers who graduate with degrees relating to the Cedar community, who then go on subsequently to work at ARL for a few years, or excuse me, AFRL, which is the Air Force Research Laboratory at Kirtland Air Force Base. And the last one I want to cover is the 2nd Space Weather Squadron. They are out of Offutt Air Force Base in Nebraska, and they are the military analog to the Space Weather Prediction Center that's in Boulder, Colorado. So anything that the Space Weather Prediction Center does, Offutt does. And yes, they do communicate. I've actually been having some of those conversations. There is communication across, but there are definitely different capabilities that they have, and there are different communication levels and responsibilities that they have for the work that they do. Theirs is more on the monitoring side, less so on the research side, but they do have positions available. And all of the units I've just highlighted have positions available. And the way you find those positions is through a place called USA Jobs. Go into the site, you can see the URL there, and I think I put the hyperlink into the slide itself, so when they share the slides to you, you'll have it. You go in there, search space, and you'll see what's available currently. I am actually thrilled that I've been able to get secure funding to hire a research fellow, so we'll actually have the first space weather research fellow at West Point starting this summer, later this summer, and we did it through USA Jobs. I did a quick search before coming here, and there was an Air Force and I think a Navy one. There were 1 or 2 that were out there that were either space weather or space physics related, but this is a way to find those opportunities. And of course, you don't have to work with us to be able to collaborate with us. just contact us. My email is there, and again, with the more detailed slides, I'll actually have POCs across each of the service academies and the graduate schools, so that if you see something that you're interested in or it ties to your research and you would like to talk to them, please feel free to do so. Okay, so then I guess it's time for questions. And it looks like the first one up is it possible for a foreign researcher to enter the Army for research? If so, how is it feasible? So I'm going to take two twists on this question. The first is it possible for a foreign researcher to work at one of the DoD service academies or at AFIT or MPS? And the answer is yes. There are limitations, but as long as basically, as long as you can get a work visa, then you are able to work at the academy. You go through the regular interview process, the application interview process, just like you would at any institution. Now, as far as entering the Army, we do have foreign members of our military, but I'm less knowledgeable on that, so that's one of those answers I'm going to have to get back to the community. I know there are paths to come into the Army as a foreign national. I do not know if you can specify it on the Army side as a researcher, but I know on the Air Force side they do have scientist specialties where that is your job, is to do research. So there are some opportunities, and that's that question that I need to get answered for you. Are there any other questions? Okay, so Major Perez and I will be here all week. You may not see us in this jacket, but certainly in uniform, so it's easy to find us. And I am happy to answer any questions that you may have. Thank you for your time.
Thank you, Dr. Loucks, for the wonderful talk. Now we will take a quick 25-minute break, and we'll reconvene at 9:15 for the first lightning round.